So in this video you're going to learn how to write electron configuration for any atom or an ion. Now we'll discuss what you already know from the GCSE level. Then I'll tell you what you have to know now in A level. Take an example of sodium. You know sodium has got 11 protons. The atomic number of sodium is 11. So because it has 11 protons, there must be 11 electrons. Because the atom as a whole is neutral, the number of plus charge must match the number of the negative charge. See, in GCSE, you know how to write the distribution of electrons for sodium. You write 2 in the first shell, 8 in the second shell, and 1 in the last shell. Say, take this diagram. You got the nucleus in the center. This is the nucleus. Surrounding that, you got 2 electrons, and this is in shell number 1. You can also call this as the first shell. In the second shell, there are 8 electrons, and in the third shell, which is also called shell number 3, so there is 1 electron. So all put together there are 11 electrons. So this is how you learn to write in GCSE level. But in A level, you will write like this way. So this is in more detail. So you write this as the same electron, the same 11 electrons. You're going to write it as 1s2, 2s2, 2p6, and 3s1. Now, if you know the concept, this is very easy to write these type of configuration numbers. In fact, so I'll tell you now how easy is this. See, altogether there are 11 electrons. Now just count the numbers that's in the power. It's a 2, 2, 4, 10, and 11. So all these added up will give you 11. Now understand how you used to write this 2, 8, and 1 in GCSE level. In the first shell, the shell number 1, there are 2 electrons. Okay, you can match the shell number 1 with this number over here. So 1 in shell number 1, you got 2 electrons. In the second shell, you got 8 electrons. That is shell number 2. There are 8 electrons. So match this number 2 here. You got 2 here and 2 here. So you got a clue now. This is the first number here, tells you the shell number. So in the shell number 2, there are totally 2 plus 6. There are 8 electrons. And in shell number 3, that is n is equal to 3, the third shell, there is 1 electron. So if you compare that in this notation, you got this tells you the shell number and the number of electrons on the top. The only thing that which is not very clear at this stage is these symbols S, P, SP. Okay. Now these are the 4 symbols you have to learn: S, P, D, and F. In this above example, you see only the symbol S and P used. But if you write this electron configuration for say aluminum or silicon or a boron, you will see this letter S, P, and D. And if you write for say for example iron like Fe, or uranium, you'll end up seeing this F also. So this is what you have to learn. Okay. Now this is a very easy, easily you can score, you can get full marks on questions from this topic. See, in GCSE you were told like this. You were told that every atom there is a nucleus, and surrounding this the electrons will be going around this nucleus. So this is what you have been told in GCSE. So it means the electrons are going in a circle. So even use this word called circle. So in GCSE you say that electrons are going in a circle. So they are going around this nucleus in a circle. Okay. Now this is okay at the level of GCSE, but when you start understanding physics and quantum mechanics, so this type of simple definition will not be true. So the reason is, just take this simple concept what I've been told in GCSE. You got a nucleus. I'm going to write this as Nu, and assume that there's electron here. Electron, okay. So you know the electron will keep going around the nucleus, okay. So if electron is moving, that means it is losing the energy. Losing energy. You know that when something moves, it does the work. Whenever you do the work, you lose the energy. If you run, if you walk 100 meters, you lose the energy. So if you think electron is moving around the circle, around the nucleus, that means it is losing the energy. So eventually, after some time, the electron should fall into the nucleus. So but that doesn't happen. So that means electrons will never go around the nucleus. So if somebody asks the reason why it is not so, you can just say, if electron is moving around the nucleus, it must be losing the energy. So when something goes around, loses energy, it will obviously eventually it will fall into nucleus. Say for example, so it should work like this way. You got a nucleus. So assume that electron is over there, okay. So it will be going round and round and round and round. After some time, when it loses energy, it will try to go circle near to the nucleus, and eventually what? So eventually it has to fall into nucleus. So this doesn't happen. So when somebody says revolving around the nucleus, okay, it is not 100% accurate. So you know why. The next simple concept you have to make it very clear is, that electron is moving around the nucleus, okay. So take for example sodium. Now sodium has got 11 electrons. Now the next thing is, we know that, okay, assume that these 11 electrons are revolving around the nucleus. The first electrons are near, and the next 8 electrons are here, and the last one is here. So this is because it has got the electron configuration of 2, 8 and 1, okay. Now the questions you have to ask is, these 11 electrons, will they be all going together, or is that these two will be going together, or here what happens here is these 3 going together and these 4 do they go together, and this one, so will they be going in a different groups, or will this be turning on anticlockwise? So when somebody says it's revolving around the nucleus, the question is does it move clockwise or anticlockwise, or both? Okay, so these are the questions you cannot answer. So nobody knows whether electron go in clockwise or anticlockwise, and nobody knows do they go in a circle, do they keep revolve? We know it doesn't revolve, okay. Now these at A level you'll come to know how exactly when somebody says electrons are moving around the nucleus, okay, you learn what exactly the moving around the nucleus mean. So is it, do they go in a batch, or do they go, a few electrons will go clockwise, or some will go anticlockwise? So all these things you have to learn. Now the next question you have to ask is, okay, electrons are going around the nucleus, it's fine, but how far from the nucleus they'll be going around? So one possibility is, take for example this sodium. Is it 2 electrons are here, the remaining 8 electrons may be over here, and the remaining 1 is here? Is this the way the electrons are configured? Or the second possibility is, the same sodium nucleus, Na plus. So is it possible that the first two electrons, rather than being near, they are far away? Or is it possible that the next 8 electrons are here, or are they this far from the nucleus? In the last one, is it over here? Now, so to understand this concept, what the scientist called Rutherford. What Rutherford said is, so electrons always go, or always reside in a fixed energy band. It's called a fixed energy band or fixed energy level. Okay, so to understand this, what do you mean by saying electrons are always at a fixed energy level? It means for sodium, for example, the first two electrons are at this distance here. The remaining 8 electrons are here, at a distance, this distance from the nucleus. The last one is at a distance from here, from the nucleus. Okay, so these two electrons, they are in a fixed energy level, fixed energy band. You can think about this like a potential energy. So assume that on the earth, say at a distance of 10 meters, okay, if you keep a ball at distance of 10 meters, whether you are at this position A or if you move to say some other place B, but at the same height 10 meters, the ball will have the same potential energy. So I can say that if I draw a line here, so this line around the earth, which is 10 meters above the ground, will have the same potential energy for this ball. So this is called as an energy level. So apply back to this the sodium atom. So in sodium atom, the first two electrons are at a energy level which is some distance from nucleus. The remaining 8 electrons are in a fixed energy band, energy level at this distance from the nucleus. The last electron is at a distance in this fixed energy band, okay, which is the distance of this much from the nucleus. Okay, now all sodium atom, take one more sodium atom, in this atom also exactly at this distance, say d1, the first two electrons will be there. Now this is the energy band, and the next 8 electrons are exactly at the same distance as it is in this sodium atom. So what Rutherford said is, electrons will not be revolving in random. Okay, so electrons are going around the nucleus, but they will be at a fixed distance from the nucleus. Two will be exactly at this distance. Okay, now this distance from nucleus depends on the atom. So take for example hydrogen. So hydrogen has got so one proton and one neutron. So for hydrogen, it has got only one electron. Its energy band will be here. So the electron is here, the first electron is here. Okay, take next helium. Helium has got 2 protons, so it will have okay, this is the nucleus of a helium, 2 protons. So for helium, the same first band will be that these 2 electrons will be in its own energy band. So compare the energy band. The first, see, both are shell number 1. This also the first shell, this also the first shell. So this is the first shell of hydrogen, this is the first shell of helium. So first shell of helium is at a different distance from the nucleus when compared with hydrogen. Now what you have to understand here is, every atom will have its own energy band. So take any nucleus, its first level will be here, its second level will be here, this is n is equal to 2, this n is equal to 1, and this third level could be a bit near here. So this is n is equal to 3. Okay. Whereas for some other atom, so if this is a nucleus, so the first could be here, the second could be here, this is the energy band 2 for some atom, the third could be here. So the third one is further away from this second band, whereas in this scenario the third band which is here, or a third level which is here, which is just very near to this level shell 2. So what you have to keep in mind is every atom will have its own energy band. Use this word energy band, okay, or energy level, okay. Now, so what Rutherford said is, he said electrons are not just going in random in circles, they go in a fixed circle. We'll not use this word fixed circle because I told you electrons, they don't go in a circle. But at this stage, just you can use this word. They go in a fixed distance from the nucleus. That fixed circle is called as energy level for that atom, or energy band for that atom. Now let's go deeper into this concept of a shell. So now we know that electrons live in a shell, and these shells are given the number starting from 1, which is the shell near to the nucleus, then shell number 2 and shell number 3. Sometimes these are also called as principal quantum number. So both mean same, principal quantum number or shell. Okay. So now you know that for sodium there are 3 shells with the shell 1, shell 2, shell 3, and shell 1 has got 2 electrons, shell 2 has got 8 electrons, and shell 3 has got just 1 electron. Now you need to understand what is this shell made of. So every shell is made of a subshell. Shells are made of subshell. This is where you will come across SPDF. So shells are made of subshells. Take for example the very first shell, that is the shell n is equal to 1. So the main shell n is equal to 1, this has got one subshell, and the name of the subshell is called S. It is S subshell. Likewise, the next shell, you have to memorize these things. The next shell n is equal to 2, it has got 2 subshells. And the names of those subshells are S and P. The shell number 3, the third shell, it has got 3 subshells. It has got S subshell, P subshell, and D subshell. For n is equal to 4, there's a fourth shell. This has got 4 subshells, where it has got S, P, and D and F. Now for n is equal to 5, okay, you still have the same 4 subshells. So there is no 5th subshell. So these 4 subshells are enough to describe the entire periodic table. So keep this in mind. So now we know that you're going in detail now at A levels. So every shell is made of a subshell. First thing, the very first shell has got only one subshell. That's called, the name of the subshell is called S. And the second main shell has got 2 subshells. They're called S and P. And the third main shell has got three subshells called S, P and D, and the fourth main shell has got four subshells inside, which are named S, P, D and F. So now you want to understand how this S, P, D, F subshells are used. So what I've done here is, you got a nucleus, the sodium nucleus, and this is the first shell, this is the second shell, this is the third shell. Now we know that in the first shell, n is equal to 1, there is only one subshell S. In the second shell, there are two subshells called S and P. And in the third shell, you got S, P and D. For the timing, you can forget the shell number 4 and the subshell F. I don't think you got that in A levels F. So here we know that for sodium, in the first shell there are 2 electrons. Now I can say that both these 2 electrons are in the S subshell. So for sodium, the S subshell has got 2 electrons. So they have colored here, S, P, D. P is the blue. So we are done with the first shell. So now we know that in the first shell, both the electrons, they reside in the S subshell. Now go back to this. Now we know that for shell number 2 or the quantum number 2, there are 2 subshells S and P. So I have written here S and P. So these two belong to the shell number 2. So now we have to show these 8 electrons residing in the main shell 2. So the way it is organized is, the 2 electrons are in the S shell. So out of 8, take away 2. The 2 are in the S subshell. The remaining 6, they are in the P subshell. That's it. So now altogether in shell number 2, you got 8 electrons. The two in the subshell S and the remaining 6 are in the subshell P. Then we have done with this one. Okay. The next one is the remaining one cell, 1 electron of sodium. So we know that in the third shell there are 3 subshells. You got S, you got the blue one P and the green one D. But you can see here the red one. I'm going to explain this in detail later part of the video. Okay, but now just a introduction. Okay, see the S shell is near to the nucleus compared to the P shell or the D shell. So when the way you put the electron is, electron will always go to the lowest energy band. So here the S is close to the nucleus, so you say that this has got a low energy. Very similar, compare this with the gravitational potential energy. So if you got a ball here, ball there and ball there, now this is Earth. Okay, now you got the same ball at 3 different distances from the Earth. The ball near the ball number 1 and 2 and 3, the ball 1 has got less potential energy than ball 2 and compared to ball 3, because ball 3 is further away from this Earth surface. Exactly the same thing we can apply the logic here. The S subshell is near to the nucleus, so it has a less energy. This circle has got less energy, so electron will try to fit there first. Once it is full, it will go to the next, that's the P subshell, sorry, because P is nearer to nucleus than the D. So P, so we know that, and also there is one more thing we already know about P shell now. A P shell can have a maximum of 6. We also know about S shell now, S subshell, sorry. So S subshell, it can have a maximum of 2 electrons. Likewise, a D subshell can have a maximum of 10 electrons. So you have to keep this in mind. Okay, you have to remember that. And the F subshell can have a maximum of 18. Sorry, it's 14. Sorry, maximum of 14 electrons you can put in F subshell. So these numbers you have to memorize. So S can have a maximum of 2 electrons. P can have a maximum of 6 electrons. D can have a maximum of 10 electrons. And F can have a maximum of 14 electrons. You will understand this SPDF concept by taking one more example. So with this knowledge, now you can write the 1s2 2s2 concept. Now how do you get that number? See, in the first shell, let's go back to that 1 second. Okay. Now sodium has got 11 electrons. So you got shell number 1, 2 and 3. In shell number 1 you got 2 electrons. Shell number 2, 8 electrons. Shell number 3, 1 electron. Now we know that every shell is made of 1 or 2 or 3 subshells. So in the first shell it has got S subshell, and this S subshell has got 2 electrons. That is, the way you write that is the shell number main in the shell number 1, in the S subshell you got 2 electrons. Now next, so in the second shell there are 8 electrons, but now you know second shell has got 2 subshells S and P, and the 2 electrons are in S shell and the remaining 6 electrons are in the P shell. So the way you write that is, the second main shell in S subshell I got 2, and again in the second main shell in the P subshell I got 6. So 2 plus 6 is 8. Now for shell number 3 there is 1 electron. Now you know that shell number 3 has got 3 subshells S, P and D, but because there is only 1 electron in sodium in the third shell, this 1 electron will be in the S subshell. So the way you write that is, in the third shell in the S subshell you got 1. That's all. So it is 1s2 2 2s2 and 2p6 and 3s1. Now this is what you have to learn in your A level. Take one more example now. So we'll take chlorine as an example. So chlorine has got 17 electrons. So at the GCSE level you write this as 2, 8 and 7. So this is in the first shell, this is the second shell, this is in the third shell. Now apply this subshell concept. So you got the nucleus, I'm going to write this as a plus. The first shell has got only s orbital, and the second shell has got it's not orbital, S subshell and the P subshell. And the third one, the third shell has got the S, it has got the P, and it has got the D. Even now in this example I don't think we'll be using the D. Okay, so let's put the mark. Now this is the shell number 1, these two belong to the shell number 2, and these 3 belong to shell number 3. Now you know that the S subshell can have a maximum of 2 and the P can have a maximum of 6, and D can have a maximum of 10, and the F can have a maximum of 14. So try to fill the electron structure now. So let's see about, let's check with the 2 electrons in the first shell. So first shell, both the electrons will be in the S subshell. So I'm going to write at the same time. So this is the first shell, S2. So we're done with this one. Let's see now the second shell. There are 8 electrons second shell. You know that in the second shell you got one S subshell and you got a P subshell. So both will give you 8 altogether. So 2 electrons will be in the S subshell. The remaining 6 will go in the P subshell. 6. Now we have done this thing. So I'm going to write that. So it's 2 in the second shell. 2 will go to in the S subshell. The second shell, the remaining 6 will go in the P subshell. So we've done that. Now the third shell, the 7 electrons. So in the third shell, you know that in the third shell we got S, we got P, and we got D. You know that S can have a maximum of 2. So first I'm going to put 2 electrons here. 2 electrons here. So when you take away 2, you're left with 5. So P subshell can have a maximum of 6. You know that. So the 5 electrons will go in the P shell. P subshell, sorry. P subshell, okay. So the way you write that, this number is, in the third shell, the 2 electrons will go in the S subshell. In the third shell, the remaining 5 electrons will go in the P subshell. So this is the electron configuration for chlorine. We'll try one more. Now can we do this without writing these circle diagrams? Take for example, start from the beginning, say hydrogen. So hydrogen has got 1 electrons, and that must be 1s1. So this is the first shell, and first shell has got only one subshell called S. So this single electron must go there. Helium, it has got 2 electrons. So it will still in the first shell, subshell S2, because you know that S can take maximum of 2 electrons. Next is lithium. Lithium has got 3 electrons. So the way you write in GCSE is 2, 1. Sometimes write first in the GCSE way and then you can easily convert. But writing GCSE way, you'll come to know how many shells are there. So there are 2 shells. So in the first shell, 2 electrons are there. The second shell, the remaining 1 will go into the S subshell. You got beryllium, which is 4 electrons. Now again in GCSE we write 2, 2. This is the shell number 1. This is shell number 2. So first shell you got only S subshell, which has got 2 maximum, and in the second shell this other 2 electrons will go. So 1s2, 2s2. So next will be boron. Boron has got 5. So now you can start. You can once you write 3 or 4, you can solve this mentally. So I can write. So this is 2 and 3, the GCSE way. So 1s2, 2s2, and 2p1. So here you know that in the second shell you got S orbital and not orbital, S subshell and P subshell. S can have a maximum of 2, P can have a maximum of 6. So after it takes away the subshell S, the third electron will go in the P shell, 2p1. So try this without writing into the GCSE level. So next is a carbon. Carbon has got 6 electrons. So that should be 1s2, 2s2. You already got 2 plus 4 electrons. The remaining 2 has to go to 2p2. So next is a nitrogen, which is 7. So 1s2, 2s2 and 2p3. So when you add up these electrons, that must give you the total electrons. Next is the oxygen, which has got 8 electrons. So 1s2, 2s2 and 2p4. Next you got fluorine. You got fluorine is 9. So you have got 1s2, 2s2 and 2p5. Next is you got neon, which is a 10. So you have got 1s2, 2s2. So in GCS you got 2 and 8, isn't it? So 2 and 8. So this is the first shell. The second shell you have to put 8. So 2 will go in the S subshell. The remaining 6 will go in here. Okay. Next is sodium 11. We have done that already. Sodium is 11. Okay. 1s2, 2s2, 2p6. So sodium is 2, 8 and 1. So this is the first shell, second shell, and this one electron go in the third shell. So the third shell it starts again from the S orbital. Sorry, S subshell. I don't know why I'm saying orbital. You're going to learn about orbital soon. S1. Okay. Now important points again. So you have a nucleus here. Nucleus. So this is the first shell. You got only S. This is the second shell. Now this is say n is equal to 1. This is the second shell, n is equal to 2. You got S shell. You got P shell. Now this is n is equal to 3, the third shell. You got the S subshell. You got the P subshell. And you got the D subshell. Now this is for third. Now you got the fourth subshell. Sorry, fourth shell. 4. In the fourth one you got S. Write it over here. Yeah. So in the fourth one you got for n is equal to 4 shell you got S subshell. You got P subshell. You got D subshell. And you got the F subshell. I'm going to put that as this color, rainbow color. Now this is the F subshell. Okay. Now remember this. In S you can have a maximum of 2 wherever it is. S in the first shell, or S in the second shell, S in third shell, or S in the fourth shell. Doesn't matter. The S subshell can have a maximum of 2 electrons. Next, the P subshell can have a maximum of 6 electrons. Doesn't matter whether the P is in second shell or third shell. Remember, the P subshell starts from second shell onwards. See, first shell doesn't have P and D or F. First shell only has got S subshell. Second shell has got both S and P. See, that is why the maximum number of electrons you can put in second shell. How many? In the second shell you got S and P. S can take 2 maximum, P can take 6 maximum. So that is why you say that in the second shell the maximum is 8. What about here? In shell number 1. In shell 1 there is only one S subshell which can take maximum of 2. So only 2 electrons can be put in the first shell. Now the D subshell can have a maximum of 10 electrons. Okay, remember that. You'll come to know why it is 10. Okay. Now, so here again D subshell starts from the shell number 3 onwards. Shell 2 doesn't have D subshell. Shell 4 has got D subshell. So the subshell D starts from third shell. So S can have a maximum of 2, P can have a maximum of 6, D can have a maximum of 10. So altogether in shell 3 you can have 18 electrons altogether. So to it. Let's see how about in the fourth shell. So F subshell can have a maximum of 14 electrons. 14. So you can have 2 here, you can have 6 maximum here, you can have 10 maximum here, you can have 14 maximum here. So all put together you can have totally 32 electrons here. So it's 20. So this is 20, 30, 32. Okay, all together. Now, so if you use only the first 4 shells, you can go up to, in the periodic table you can go up to 2 here, 8 here, plus 18 here, plus 32 here. Okay, so this will give you 50, 60. So you can go up to atomic number 60. Now again keep in mind the distance of the subshell from nucleus. So s orbital is close to nucleus, and in the second shell the s is close to nucleus than the p. So for that reason, the electrons, when you distribute the electrons, the s subshell, you have to first fill the s subshell. Only after you fill the 2 electron s subshell, you can go to the p subshell. And when you start filling electrons for shell is equal to 3, the s subshell is near to the nucleus than p and than d. So first you fill 2 electrons in s, then you fill all the 6 in p, then only you fill all the remaining 10 in d. This is how it works. Okay, you can use this word near to nucleus. You learn that you have to start using these words. Say this subshell is near to the nucleus. So near to nucleus also mean it has got low energy. Remember the example I gave about the gravitational potential energy. The further you are from the earth, you have got more potential energy. It's exactly the same thing. Think the nucleus is the earth, and see the distance of this s orbital and p orbital. S is closer to this nucleus, so S has got low energy. So atom will always try to have low energy as possible. So it tries to fill its electrons, okay, to the lowest energy, close to the nucleus as possible. Now this is very, very important for you to understand. Okay, this is we call it anomaly. Now here I have got the SPDF for 4 shells. So this is S, this is S and P for second shell. This is S, it is a P and D of the third shell. Now this is the confusion here, this is the anomaly. Okay, this red line here, this is a S subshell but belonging to the fourth shell. So this is S, P, D and F. Okay, this is something you have to understand. Okay, everything you know everything about this. Okay, why it is. Okay, so somehow, don't know why, God knows. Okay, the S subshell, okay, see the S subshell of fourth shell is closer to the nucleus, than the D subshell in the third shell. So look at here. Now here you got S, you got P and D. This is the third shell. See, third shell has got 3 subshells, and this is for the fourth one. Not everything, remember. Now this and this and this. Okay, so in the fourth shell you got S, P, D, F. The fourth shell has got the F subshell. Now if you look at this diagram, the S, okay, the S subshell in the fourth shell is closer to the nucleus than the third shell of the, and the D subshell of the third C. See, this is the third shell D, and this is the S shell of fourth shell. Okay, S subshell of the for level 4. You can use this word called level, okay? The level, rather than calling subshell, subshell, okay? Just say level 1. So this is n is equal to 1, level 1. This is level 2, level 3, level 4, okay? Now you have to understand this, okay? The S subshell of the 4th level is nearer to the nucleus than the D subshell of the 3rd level. So for that reason, okay, the 4s shell will try to fill before, okay, we'll try to fill first or try to fill before the 3D shell. Okay, we'll take an example of this. Keep this in mind, okay? Now remember, any S subshell will have maximum of 2 electrons. Okay. Now take an example here. So see, take this potassium. Okay, potassium has got 19 electrons. So at the GCS level, you would have written 2, 8, and 8, and this will be 1. So totally, 18, isn't it? 2, 8, 8. That's what you write in GCS level. Okay. Now try to write this in, let's try to fill this in because you're doing this for the first time. I'm going to use this diagram now. Okay. This is the level 1. You got S. Level 2, you got S, and you'll have P. The level 3, you'll have S, and you'll have a P, and you'll have its D. Okay, so this is the S, this is the P, and this is the D of level 3, and this is the S, and this is the P of level 2 or shell 2. This is the S of shell 1. Now I'm going to write, that, see, next we have to write about the level 4. That's the 4th main shell. But in the 4th main shell, the S subshell will be before the D subshell of level 3. So this belongs to 4S. Then the rest is as usual. So you'll have the D subshell of level 4. You will have SP, sorry, this is SP, not D. Okay, you'll have this is the D, and this will be, sorry, not D, this is SP, isn't it? SPDF. So this is the P, and this is the D, and you'll have the F. Okay, now start filling this thing now. So we have to fill 2, 8, 8, and 1. So altogether, okay, we got 19 electrons. Okay, so first two electrons are gone. Now I'm going to start writing here. So I got 1 S2. The remaining 8 electrons. Okay, so level 1 is full. Go to level 2 or shell 2. So 2 will go to S, and remaining 6 will go to. This is the normal way of filling. Okay, so we are done with this 8. So that is 2S2 and 2P6. We have done. Next, we have to start filling this 8. 2 will go here, 2 will go here, that's fine, and the remaining 6 will go here. Because remember, we are filling in the order of how close it is to the nucleus. Okay, now after we fill this S, the next closest to nucleus is the P subshell of level 3. It can take 6. Okay, we have done with this one. Okay, now that is, we have consumed 3S2, we have consumed 3P6 also. Now if we did not know about this 4S being closer, what we would have done is we would have just given the 1 electron to the D level, and we would have written here the next will be 3D1. Okay, but this is wrong, isn't it? Now you can't do this thing, because now we know that the D subshell of level 3 is further away, or in other words, the S subshell of level 4 is closer or comes before the D. So this electron will go here. Okay, so I'll end up doing 4s1. Okay, so next one, say next is the just see how easy it is to write these diagrams now. For calcium, calcium has got 20 electrons, just one more than potassium. Okay, so it's same thing, isn't it? It's just one more than potassium. Okay, it is a 2, 8, 8 and 2. Okay, now we already done this for 2, 8, 8 and 1. We already done for potassium. This is the diagram you got so far, what you got in front of you. Okay, now we just had to worry about one more electron here. There's one electron here. Okay, now S, remember in this structure now the S subshell has got only one electron. It can take two, so it will have one more here. So this, so the electron configuration for calcium will be same thing. Everything up to the potassium is same. 1s1, 2s2, 2p6, 3p6. Okay, 4s2. Now go the next one. Next is Sc, calcium something. Okay, Sc, which has got atomic number 21. Okay, so this is one more than calcium. Okay, now so far, okay, we have to fill just one extra electron now. Where does it go? What the next shell, subshell near to the nucleus? So this we have done full. Next is now we are going to the D subshell of level 3. Look at that. Okay, now same thing up to here is the same. So cesium will be same thing. Okay, you'll have the same thing. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and up to here we know that there's one electron for cesium, that is 3d1. You have to be very, very careful when you write this electron configuration. Okay, here, but sometimes see, you know that 4s2 fills before the 3d. Okay, but you are also allowed to write this in a proper order. Okay, you know that by looking at this, you know that 4s2 fills before 3d. That's what it happens. Okay, but if you're asked in the exam, you can also write in the proper alphabetical order. Okay, it's still valid. I can still write this as 1s2, second shell, third shell. I can write 3d1, then I can write 4s2. I can do like this also. I could have also done the same thing for yeah, this is the first one, isn't it? Okay, this one. Now go the next one. You have titanium T. Okay, Ti. Now this has got electron number of electron 22. There's just one more than cesium, just one more than that. Okay, so one extra electron. Okay, now remember, now what we have got so far is, okay, we still have got the D subshell can take maximum 10 electrons. You know that we have just got one here, so I can use that. Everything is the same. This is same, this is same. Only here this becomes DT2. Again, next one DT3, DT4, and so on. Okay. So look at this table I found on of the book. Now next, in the next video, I'm going to explain what this arrow, up arrow and down arrow is. You have to understand this thing. So look at this hydrogen first. Okay, the first hydrogen. So you got 1s. That's only one electron in 1s. Next is helium, 2. So here the arrow here means, okay, here there are 2 electrons, one up and one down. Okay, so I'm going to introduce a few words here. It's called as a spin. Okay, now when I say this S subshell has got 2 electrons, one electron will be spinning clockwise, another electron will be spinning anti-clockwise. Okay, so to represent that, you use one as a down arrow, other one's up arrow. Doesn't matter whichever it is. You can say this is the up arrow, one down arrow. So these arrows in 2 different directions, it's just telling you that the two electrons that are together, they are spinning in opposite direction. And you're going to learn what is called orbitals. I'm going to start in the next video. It's called orbitals. Okay, so take lithium. Lithium has got two in the S shell and one in the shell number 1. This is in shell number 2. It has got in the first subshell it's got 1. Okay, so this is 1s2 and a 2s1. So take for example here we are discussing about potassium. Potassium, after this 3p, in the third shell you got S, P and D. In the fourth shell you got S, P, D and F. Okay, but now you know that the S subshell is nearer to the nucleus than the D subshell of level 3. Okay, so that is fine. After you fill S, after you fill D, you have to fill the S subshell of level 4. Only after you put 2 electrons here, you can start filling this one. There is a nice, let me check that. Okay, it's very easy to understand this thing. Look here, in some books they write like this way: 1s, this is a 2s, this is a 2p, this is the third shell, 3s, 3p and 3d. Understand this very easy. 4s, 4p, 4d, 4f. Okay, so you got 5s, 5p, 5d, 5f, 6s, 6p, 6d and 6f. Okay, now this is the shell number 1 and this is shell number 2 and this is shell number 3 and this is shell number 4 and this is shell number 5 and this is shell number 6. Okay, now put the arrow like this way, arrow. Okay, this, 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 okay, it means first fill 1s, then you fill 2s, then you fill 3s, and sorry, you start from arrow, start from, isn't it? After that you next you fill 2p, 3s, then you fill 3p and 4s. See, look at here, you got that 3p, 4s. You follow this diagram, okay. You can also what some people do is they also put like this. Wait a minute. Yeah, so this is n is equal to 6. Okay, just write down this is the shell 1, shell 2, shell 3, shell 4, shell 5 shells. Okay, just start an arrow from here, this. Okay, go from here, come from here, then go from here, come from here. Look at that, just follow this arrow. Okay, tells you what order you're going to fill: 1s, 2s, 2p, 3s, 4s. Oh, it come wrong, isn't it? It can't be 4s though. So after 3s, okay, you have to go to 3p. So no, sorry, this may not work. Okay, just do this way. So first you fill that, second you fill that, third you fill 2p and 3s, then you fill 3p, 4s, then you fill 3d, 4s thing. Okay, now you have to practice. Okay, what I'll give is I'll give few problems. Once you understand the theory, come back to me, I'll give some problems to you. Okay.